Hey everyone, in this video I want to talk about a huge cosmic level occurrence. In this world we have these cosmic level events, these alignments, these convergences that most likely will never happen in our lifetime. For example, we just had the conjunction of Jupiter and Saturn, something not last seen for 800 years, but that just seems a very common occurrence compared to what I'm going to talk about today. And that's really this alignment of my training and Azure to this new technology, Project Bicep. Managed to keep a straight face, I'm quite impressed. So my goal for this video is to really go through Project Bicep, what it is, why we want to use it, really where it came from. Now, I've been promising this video for a while. I said once it hits version .3, because .3 is really this production-ready ARM template parity release, which we now have. So if we take a step back for a second, and as always, if this is useful, please like, subscribe, comment, and share. So we think about Azure, and I always draw this picture. I can kind of think about, well, Azure is this set of capacity all throughout the world, many different regions. On that capacity, we build many different services: compute, storage, network, machine learning, huge ranges of services. And the way we interact with that is through kind of this Azure Resource Manager. And that's really what drives all of our interactions, be it through a REST API, PowerShell, CLI, whatever. And I can use all of those different things to create resources, but really behind the scenes, everything is stored in this configuration format of JSON. I can actually go and look, and if we were to go and look at resources.azure.com, I can head over and say, well, let's look at my subscriptions, let's look at my dev subscription, let's look at my resource groups, let's just kind of pick one of these. I can see the resource providers that give me things like storage accounts and virtual networks. And then within here, I can see, hey, look, there's a storage account. And I can see this JSON format is how the resources are actually defined. I can see things like the SKU. The SKU has a name, it has a tier, there's a name, for example, of the storage account. So this is how the resources are actually stored under the covers. I can even go to the portal, I can look at any resource I want, and you actually see under automation, for really anything, you have this option to export template. And that will actually create a JSON template of that resource. So once again, I could go to the same resource, and I can see export template. And once again, here is the JSON that defines that resource. So under the covers, everything is in this ARM JSON format. So we have this ARM JSON. And this is really designed about being a configuration format. It's great for the system to be able to utilize. Now, the best way I can think about is actually provisioning resources is by creating an ARM template. And then I basically submit that to the Azure Resource Manager. I can submit it through a RESTful call. I can use the AZ CLI, PowerShell, whatever. And the benefits I get here are numerous. Firstly, this is declarative. What I'm doing is, this is what I want the end state to be. I'm not telling it how to do it. I want a storage account. For example, if I was to look at a very basic template, if I go and look at my files, I've got a storage account with containers file. You can see I have this JSON file. And what I'm basically doing is I'm saying, hey, look, I want a storage account. It's got a certain SKU type. It's got a name. And I want this thing. I want this created. And that's great. So I can actually go through here and I could just deploy this template. Now, right now, if I was to look at the resource group this is going to deploy to, just so you can kind of prove there's no kind of smoke and mirrors going on, it's empty. So what I can do is I can deploy that ARM template. So that's now going to go through and it's going to look and say, well, what's there right now? What is the desired state in that JSON template? And as Picard would always say, make it so. And so it's this declarative. I just have to say, well, what do I want it to actually be? Now I can just keep rerunning that. So a great other thing is it's idempotent. I can just keep rerunning that same template. If the reality matches the state, it's not going to do anything. But it's a great way to tell, well, is it that state? I can go and do things like, well, detect drift. It lets me do infrastructure as code. I'm defining those resources as code. And because it's as code, what's super powerful here is I can do things like version control. Very commonly, we're going to have something like some kind of Git repository where I'm going to store that template to actually use. It's very common in my CI/CD pipelines. The first thing it will ever do is actually call that template to make sure the resources are actually as I want them. Now we can see now that finished. We can see, hey, it went through, it did that deployment. The portal can take sometimes 30 seconds to catch up, but hey, look, it's there. There's the storage account, and I can also see it created a container because within my JSON file, what I actually had in here was, hey, yes, I want you to create a storage account and I want you to create a container as well. So it did those things. And one of the things about this is it is declarative. I can pass parameters. I can have parameter files, which are JSON files. I can do things like what if. So here I'm going to deploy it again, but I'm going to say, hey, what if I now say I want the storage account type to be GRS? We can see at the bottom it's looking at, well, okay, what's the reality? What's the desired end state? So now it's saying, oh, I want it to be GRS. Well, what is it right now? And it's going to show me, well, actually, what I'm going to need to do is change it from LRS to GRS. See that at the bottom? And it would just make that so. So these are fantastic. This is just absolutely awesome. And one of the other nice things I get with my ARM templates is I'm showing kind of just deploying to ARM, but one of the first things it actually does is a pre-flight. And what that pre-flight does is it looks at the entire template, looks at things like what are my quotas, what are the capabilities, and says, well, will it work or not? If I was going to create 50 VMs, I only had a quota for 25, it'd say, hey, look, this is not going to work. Let's stop it now. Other technologies won't. They'll just go and create 25 and then fail. So that pre-flight is actually a super useful capability. So all I've said so far is how fantastic these ARM JSON files are. I've talked about things like, well, how great I have that what if capability to see, well, what would it do? I can confirm. I have those great parameter files. So if I had, for example, a test environment, a QA environment, and a live environment, I can use the same template. It's immutable. It's not going to change. And the only thing that would be different is I'd have a different parameter file. I'd have a parameter for test, a parameter for QA, a parameter for live, but the actual template would be the same. There's no risk of it changing going through those environments. So why am I talking about Bicep? The challenge is this ARM JSON file is really a configuration language. It's not really designed to be tooled and user-friendly like a typical programming language. If we actually go back and look at it, it's very, very verbose. If I actually go and say, well, let's look at this thing, well, there's lots of brackets everywhere. There's a schema version, there's content. I have these parameters. It's big. It's very long. And it's kind of hard to read. I have to use special parameters. Hey, it's a parameter. Hey, it's a variable. Hey, there's resources. I have to add depends on, say, okay, well, this container depends on the storage account. That tells ARM, well, okay, I have to create the storage account first. So while JSON is absolutely phenomenal in terms of a technology with that declarative nature, that idempotency, that infrastructure as code, it's really not very nice for me as a human being to author. Now, there are things to help. I already showed, well, from the portal, I can export out a JSON template. I can go to GitHub, and in GitHub, there's a massive library of getting started. There's templates around creating storage accounts and creating virtual machines. Kind of, the list really goes on. But it's still just not that friendly. Bicep is designed to actually be a language we can work with, we can actually program into. But again, I'm not forgetting about the powerful ARM template. So where we think about Bicep is Bicep kind of sits here. I create my Bicep file, and essentially I transpile it into an ARM template, which then goes through. So I get all the benefits of those ARM templates, but now I as a human don't have to worry about that fairly ugly ARM JSON syntax. I can now write in this very nice Bicep language, which has great tooling. When you think about TypeScript transpiles to JavaScript, this is the same kind of idea. Bicep is really designed around being able to be programmed. There's fantastic tooling around this. I'm going to focus on VS Code and the extension there to be able to write these Bicep files. But it's transpiling, it's going to create an ARM template. It sits on top of ARM templates. So as soon as functionality is in an ARM template in ARM, it's going to be available in Bicep as well. Straight away, it just sits on top of it. So there's not going to be a delay. Anything I can do in an ARM template, I can do in Bicep. Now, initially, what I had to do is I would actually have to do a Bicep build. So I would manually kind of have my Bicep file, I would build it to create the JSON file, and then I would kind of use those AZ kind of CLI commands or PowerShell or REST, whatever, to actually deploy it. But now with version 0.3 and above, I can use those same kind of AZ and PowerShell commands directly against the Bicep. It will compile it, transpile it into an ARM template in memory, so I never see a JSON file on disk, and send it to the ARM. So it's still using the ARM, I just don't see that template on the file system anymore. And the huge thing here really is that it's just a much more friendly format. I could quickly show this. So if we actually go over, so here I showed you this kind of very big storage account with container. I can decompile. So if I run this command, it's doing a best efforts to decompile that JSON file into an actual Bicep file. So this is now the Bicep file. And what you'll notice is it's just a lot friendlier. It's a lot easier to read. It's just referencing things like parameters directly, not using special parameter keywords or anything else. It's much cleaner. As a human being, I can kind of look at this and understanding it a lot easier than trying to work with a JSON template. But again, I get all of the goodness of those ARM templates, those what ifs, those confirms, those pre-flight checks. It's still all of that capability I'm getting with my Bicep. Okay, key point, ARM is not going anywhere. Again, it sits on top of ARM. So I still have the ARM templates. And actually one of the things that's happening is because of Bicep, they're actually making the ARM templates even better. Some of the challenges that have been there for a while are actually getting cleaned up because of the way Bicep interacts with it. So ARM is always going to be there. It's just Bicep is removing my need to worry about that ARM format. I'm going to focus on my Bicep file. Another key point, if you use things like Terraform, there's a state file. So essentially what happens is between kind of my desired state and reality, they have this kind of state file. And things like Terraform need it because Terraform work with different cloud providers, on-premises things. So they need some common format to track, well, what's reality. It's not easy for them to just look at what's reality. The challenge with the state file is maintaining it. If I have multiple people deploying, I have to make sure that state file is somewhere shared they can all get to. If something happens to the state file, there can be some pain involved. Bicep does not use a state file. It does not need it. Bicep is aimed at Azure. ARM templates are aimed at Azure. When it's doing a what if, when it's working out the drift, when it's working out what it has to do, it's comparing my desired state to reality. There is no in-between state file I have to try and work out. It's always comparing to reality. So what do I need to get these wonderful new things? So obviously Bicep today is not really integrated with the portal. It's not in the Cloud Shell just yet, but I would expect it to be there very, very soon. Remember, I can export templates from the portal, the ARM, and decompile it into a Bicep file. I can use things like AZ group export. I can use the export AZ resource group from PowerShell to create those ARM templates, and then I could decompile it. But if we think about going forward, things like template stacks, which are the replacement for blueprints, the evolution of blueprints, those will start using Bicep, I would imagine, fairly soon. So what tooling do I need to start using Bicep? Well, firstly, if we jump over, we're going to go to Bicep. And what we'll actually do is we will install the Bicep CLI. So I can install this, for example, for the Windows installer. There's ones for Mac OS, there's Linux. So this is actually going to get me Bicep installed on my machine. So it's like that Bicep executable. Now, one thing I will kind of stress to you, if I run mmsys.cpl, no, not that, wrong one, sorry. I meant sysdm. Right, let's run sysdm. I want to look at my path there, real. Sysdm, so CPL. What it's going to do when I install Bicep is it's adding it to your path. So if I go and look at my environment variables and look at my user path, what you'll actually notice is it's added here Bicep CLI. Now, I had an earlier version installed, which was still present on the system. It was in like a .bicep folder, which was a higher entry in the path, which meant it got used first. So I went and deleted that old path from my path variable and actually deleted the folder. So it's going to install Bicep onto your machine and it's going to add it into your path. So I now have the Bicep engine. So that's great. Now the next part is, now I actually, in my kind of dev environment, I can think about, okay, in my machine, I've kind of installed the Bicep engine. Now, if I'm using the AZ CLI, there's actually a special version of this now that actually supports the Bicep. So if it's version 2.20 and above, I actually don't need to install Bicep. AZ CLI will automatically pull down a self-contained version and use it. If I'm using the PowerShell AZ module, well then it's version 5.6.0. That does actually link to the Bicep in the path. So I have to have Bicep installed and then version 5.6 of PowerShell. So if I look over onto my machine, and let's see what I have in my Bicep demo, well, notice I can check my version of Bicep, Bicep-V, and great, I'm 0.3.1. That's where I want to be. Then I can check what version of the PowerShell AZ module do I have. And I'm running 5.6.0, fantastic. I can always go and check what the latest one is. For the AZ, I need 2.20 or above, and I've got 2.20. So I'm all good in terms of the versioning on there. Now you'll notice I'm actually in VS Code. So then what you also want is this Bicep extension. The Bicep extension does not require that Bicep engine to be installed on the box. It just natively has kind of the understanding of the language. This VS Code extension will auto update, but that's what's going to give me the ability to get really a lot of that very friendly authoring experience through Bicep, like the autocomplete suggestions of really what I need. Now, the first thing I'm going to recommend to get the tooling in place is really go through the Bicep tutorial. It's phenomenal. It's like, I think, 7 pages of steps. It's going to introduce all of the core things, creating your first template and deploying it. It's going to go through variables, parameters, modules, looping, expression, conditions, decompiling. It's going to cover all of that stuff. So once you've got the environment set up, my recommendation would actually be just go through that tutorial. That's going to be the best way to actually start learning Bicep and actually getting going with it. But it would be remiss if I didn't at least show this. So what we're going to do is create a very, very simple Bicep file and just see what some of that experience actually is. So over here in my VS Code, now you'll notice, remember, I had that Bicep file that it created. But there were a few kind of ugly things about what it did kind of out of the box. One of the big ones here is, well, it still has this depends on, which normally I do not need. And it's doing that because it's not actually referencing any part of the storage account. So what we'll see is if we create this from scratch, I don't need depends on in my Bicep file. So I'm going to close down that JSON file. And what we're going to do is we're just going to create a brand new file. So we're going to say new file, and we'll just call it storage.bicep. So now I'm in my empty file. Now the first thing I'm going to want to do is have some parameters. Now it has IntelliSense, so I'm going to say, hey, I want a parameter. I want to be able to pass a location in. It's going to be a string. And now what I'm going to do is, by default, I'm going to give it a value. And I'm going to use an expression. So I'm going to actually look at the resource group. Notice I'm just hitting tab. And the resource group has properties. One of them is location. So I'm just going to use, by default, the location of the resource group I'm deploying to. Great. Also, I'm just going to add another parameter, which is going to be the name of my storage account. It's going to be a string again. And I'm just going to set that to SA Saville SUS 007. Fantastic. Now I also want a storage account type. So I'm going to do param type string again equals, and we'll say standard underscore LRS. So these are just things that I'm setting some default values for, but I could override them. Now, for some of these things, there are, for example, only certain allowed values. There might be certain limits on what it can be. For example, the storage account name has to have a minimum of 3 characters and a maximum of 24. So I can actually add modifiers. I could say things like, hey, the min, notice it's tab complete, min length is 3. And I just put this ahead of the actual parameter. The max length is 24. Super easy. Well, actually, for the storage account time, there's a list of allowed values. So once again, here I could do, well, allowed, and then just add in an array. And I'm way too lazy to retype all of those in. So in this case, I can just steal those from this other thing that it generated before. So I can just say, hey, over here, my list of allowed. So now I've said what are the actual allowed values that I have for this. So great, I have 3 parameters that I've set default values for, but I can override them. I can override them by setting them as parameters on the actual command line when I call it. I could pass a JSON configuration file. So the Bicep file does not have a different parameter file format. So I have these JSON parameter files. I can use the same JSON parameter files to Bicep when I deploy. It doesn't have its own native parameter file format. It's going to use those same JSON parameter files where I had, hey, slightly different values for test and QA and live. I can use those same files, maybe add a different SQL server or resource group to apply as I move through the different environments. Okay, so now I actually want to create a resource. So to create a resource, it's super, super easy. IntelliSense is absolutely my friend here. So I start typing and it says, oh, resource, tab. Now what I'm going to do now is give it basically a symbolic link. This is kind of a friendly name, a symbolic name for the resource. It is not the name of the resource in Azure. It's just a name that I can use throughout the bicep file to reference it. So I'm going to have this symbolic name. So I'm just going to call it ST account, storage account. And then it has to have a resource type. Now notice straight away IntelliSense is giving me a whole list of things. Well, I want a storage account. So I'm just going to start typing storage. And straight away now it's got me down to storage accounts. I'm going to hit tab to get the latest API version for storage accounts. Now I have to set the properties. So I'll do equals. Notice it's telling me, hey, you need kind of the curly braces. I'm just going to hit tab. And now I'm ready. Now I can hit control space. So control space is showing me straight away without typing anything, hey look, here are some of the key things, John, you need. Okay, well name looks like a good one. And that actually shows me, notice it's required. Now remember what I did here is I have name as a parameter up here. But I don't have to do anything like special, say, hey, parameter name. I can literally just, and it's saying, hey, do you want name? Yes. So that attribute name I'm populating from the parameter name. Okay, what else do I need? Okay, well I can see, okay, location. My location, once again, I have a variable for that. Sorry, a parameter for that. So I'm going to say, well, my location is location. Then I know I need a kind. So I type K, there's kind. And it's going to show me all the different types of storage accounts. So I'm going to have a storage V2. Next, I need a SKU. So again, on S. And then it knows, well, actually, there's different properties within the SKU. So it's curly braces and control space. Oh, okay, name and tier. Name is required. So I'll have name. And my name, it gives me all of those different options. But remember, I actually have this as a parameter, my type. So what I will do here is just say, I want it to be my type. And that's it. Really, what was my level of skill there? I could hit control space and type in blob. It did everything else for me. And that's what's so powerful, that IntelliSense, as I'm using this in VS Code, makes it so simple to actually create these things. And at that point, I could basically be done. But let's just go a couple of steps further. I want to create a container in that storage account. Then I'll see kind of that depends behavior. So if we go back over to here again, here we go. So now I want another resource, remember? So, okay. So I want another resource. This time I'm going to call it, I'm just going to call it my container. I'll be very boring. And the type, well, I know it's part of a blob service. So I'll type blob services, and it's going to be a container. And it's doing something slightly weird this time. Let's do this again. So I know it's a blob services. There we go. And there's that container down there. So I'll hit tab. There we go. So now it's showing me, hey, containers, I'm creating it of this particular type. And once again, I just have to put in the attributes. Control space. Okay, I need a name. That's required. It's showing me, hey, look, name is actually required. And for the name, okay, now I want to use the storage account. So remember, we have this STACC symbolic name. So what I'm going to now do is create an expression. But also as part of that is, if we try to create strings normally in a resource template, I have to kind of do things like concat and do these fairly ugly things. With Bicep, I have this great string interpolation where I can just basically combine those things together super easily. So what I'm going to do now is for the name, well, I'm going to reference my storage account symbolic name. So I'll just do $, squiggly bracket. And I'll say, hey, look, there's my storage account. I typed S dot, and I'm going to reference here the name. And then I'm going to put it in the default. and then maybe I'll just call it images. So it's going to create a container called images in my storage account. And because it's referencing an attribute of the storage account, it knows it depends upon it. Now I might say, well, actually, I don't really like that. So instead, what I could do is I could add variables. I could add a variable called container name, and I'm going to set that to images. And now once again, I can use this nice string interpolation capability and just do dollar squiggly brackets, container name, there, and I'm done. And finally, let's output the ID of the storage account. So I can have, absolutely as we would expect, output. And again, it's a symbolic name. The storage ID is a string, and it equals storage account ID. And that's it. So you can see here, so I have a number of parameters. By default, I'm getting the location of the resource group. I have a storage account name. I'm setting a default, and I'm having some kind of modifiers, it minimum, maximum. I've got a list of allowed values for the storage account type. I create a variable, images, and then I'm just creating a storage account and then creating a container in that storage account. So it depends upon it. And I can save that. Now what I'm going to do is I'm going to build it. Now I do not have to do this. I'm only doing this to show you the JSON it's actually going to create. So what I'm going to do now is build that storage, and then we can see over here I now have a storage JSON file. So it's taken the bicep and it's spat out a JSON file. So it's got the variables. Look how much bigger it is. It's just really not that friendly. But I've got my storage account, same parameters, type, and look what it's done. It's added a depends on for the container it's going to create, because I referenced the container, the storage account from the container, so it knows, hey, I actually depend on that. Now I'm going to delete that. I'm not going to leave that around, so it doesn't actually need that storage JSON file. So that's gone. So now let's actually deploy it. So what I'm going to do over here is I've got my storage bicep file, so that's all finished. And we're going to go and actually deploy. Now, because I'm running that version 5.6, I can deploy directly from the bicep. I can use those same AZ and PowerShell commands directly against the bicep. Remember, it's going to transpile it into a JSON file in memory and submit it to ARM. So it's still going to do those pre-flights. I don't have to have some JSON file actually on the file system. And again, there's no state file involved in this. So if we actually go and look where I'm going to deploy this to, let's jump over, look at my resource groups, and I have an empty bicep demo resource group. And now what I'm going to do is, remember, I'm going to deploy that bicep file. So notice here, I'm actually just referencing the bicep file and the resource group I want to deploy it to. I'm using the regular AZ resource group deployment I want to use. Remember, that's exactly the same one as I used with a JSON file. So I'm just going to run that. F8. So now it's going through, it's compiling that in memory to a JSON file. It's looking at what's my desired state in the bicep file. What is reality? Well, reality, remember, is there's nothing there. There's nothing it has right now. And it's going to work out, okay, well, what do I need to do to make that desired state the reality? So now it's going to actually go through, it's going to create the storage account, it's going to create. So it's finished. Notice it has my outputs. So it outputted the ID as I requested. And I can see, hey, look, there's the location, which is the location of the resource group, and everything else. And then within about 30 seconds, it will show up in the portal. Right? There already. So there's the storage account, and hopefully there's my container. So it just worked. But I get all of the same features as just a regular template. I can, for example, here override parameters on the command line, or I could pass it a different parameter file with different values. I can still use what if. So let's actually run this again, saying, hey, I want it to be GRS this time, but just give me a what if. Tell me what you would do. So now it's going to tell me, hey, what I would do at this point is, well, I know reality right now, remember, is LRS. That's what we actually had inside. So we know it's LRS right now. And I'm telling it I want you to be GRS. So here we can see, hey, what I would do is change the SKU name from LRS to GRS. And there's some stuff on the container images as well. Let's combine this. AZ. So let's use AZ CLI instead. I'm going to now do the same what if using the AZ CLI. Now watch what it's doing. Notice straight away. Installing Bicep CLI v0.3.1. It does not need Bicep installed on the box. Whereas the PowerShell references the Bicep I have installed on my machine, it has to be in the path. AZ CLI does not require that. AZ CLI brings down a self-contained version that it can just leverage. And now once again, it's told me, hey, what I would do is, hey, guess what? I'm going to change from LRS to GRS. And let's actually do it then. Let's just prove I can be totally interoperable with those things. So remember, right now, that storage account is LRS. All I've done is I've changed my desired state in my Bicep by essentially overriding a parameter to now say, hey, I want it to be GRS. And again, that could be a parameter file, that JSON parameter format. And what I'm now saying is, hey, I want it to be GRS. It's showing me, because I did -C means confirm. It's showing me this is what I'm going to do. I'm going to change it to GRS. Do you want that? Yes. Go ahead. So in here now, just say yes and go. So it's going to make my desired state a reality on the system. It's going to convert it from an LRS to a GRS. Now think about if I was doing that imperatively. If I was just writing a PowerShell script, I'd have to say, well, does it exist? Okay, if it doesn't exist, create it. If it does exist, what's a different command to maybe change the type? That's the beauty of this declarative nature, is I'm just saying this is what I want reality to be. You work out what you have to do to actually make that the real world. And that's why when I think about using these technologies, again, your CI/CD pipelines, when you have that pipeline, one of the first things you're typically going to do is, hey, now I'll call my Bicep file to make sure the core resource is there, be it my app service plan or my functions or my SQL database, whatever. It might already be there. Great, I'm just making sure it is. And then I can deploy my code, run my tests and everything else. If I need to change the reality, change what I need, I don't care what's there. Just go and make this the reality. So now, according to this, it has finished, it succeeded. So if we go back and actually look again, if I hit refresh, notice, remember what we're looking at is this kind of replication. If I hit refresh, well, now it's GRS. So again, my desired state changed. I'm good to go. Now that's a very, very simple demo. As I said, there's loops, there's conditions, there are modules. And what you really want to do is kind of go through that tutorial. Modules are phenomenal because if you think about, hey, I had this Bicep file and I'm going to store them in my Git repo. So what I'll end up with over time is a whole bunch of Bicep files. Maybe it's a Bicep file to create a storage account. Maybe it's a Bicep file to create an app service plan, all these different files that create resources. I get this library. And now they become modules. And now when I actually want to do a deployment, I can say, hey, I'm going to create a new main Bicep file and basically reference the different files I need using this special module parameter. Let's just show you that quick. So if I jump over again to the tutorial page, it's got great information on, hey, using those resource declarations, conditions, existing, all that stuff. But then it talks about modules, so that I wouldn't have to change my Bicep file at all, but now I could just reference it from a different Bicep file. I can override parameters if I want to, and now use it so I can get this whole library of things that I can now leverage. I can even do things like set scope, so I can change the scope as I do deployments to maybe be a subscription. So I can actually create a resource group in my Bicep file. Maybe I want to target a different resource group. But this is really the point. Now, they're very easy to author. You saw that kind of IntelliSense experience using Visual Studio. But there is still a huge GitHub repo. You can actually go to the Bicep docs examples. And over here, just like ARM templates, there's a whole bunch of 101s. All these different things. How I want to create a simple Windows VM. There's my Bicep file. Hey, look, I have parameters once again. I have some variables. And then, oh, look, I'm creating a storage account probably for the diagnostics. Then I'm creating a public IP address. Then I'm creating a network security group. Then I actually create a network interface. And then I create a VM. And I just have the core values and attributes I actually need. So it's just so much friendlier to actually use and understand. So yes, I can start from scratch and they kind of really are nice to author. It's a programming language with great tooling, but there's still a load of things to help me. So with all that said, what does this mean? What is the future using ARM templates today, or maybe using Terraform today? If you're using something today like Terraform and it works for you, phenomenal. Keep using it. Maybe you're multi-cloud, maybe you're hybrid. If Terraform works, stay on that. Bicep is just another option. Now, if I was using ARM templates, I would recommend you move to Bicep because remember, you're still getting all the benefits, things like this pre-flight, all of these capabilities, you're still going to get. It's going to make your experience a lot nicer. So I think what we'll see is if you are kind of around that ARM template world, or maybe you're only using Terraform maybe for Azure, and maybe, oh, I didn't like the JSON format, Bicep, maybe I'm going to reevaluate that. What I think we'll see is today you probably have ARM templates, for example, in your Git repo that you call at the start of your CI/CD. You won't do that. Instead of having ARM templates, you'll have Bicep files, and you'll call the Bicep file at the start of your pipeline to make sure the resources are as you want. As I talked about, blueprints today use ARM templates to actually deploy resources. Template specs are the evolution of that. Template specs will start using Bicep. So this is really just, I think, where we're going to go to. If you're using ARM templates, you're going to migrate to using Bicep. If you're using something else, well, just reevaluate maybe why I was using the something else. If it's because I'm multi-cloud or multi-thing, great, carry on doing it. If it was just because ARM templates were ugly, hey, maybe I will go and reevaluate that. That was it. Definitely go through that tutorial. It's phenomenal. It's going to teach you everything you need to really be successful. But as always, I appreciate you watching and good luck.